Afternoon, ladies and gentlemen, here sitting with your lunchboxes for our Lunchtime Focus Keynote, day 3 now of 11th Cloud Expo. So if you're following this out there on the World Wide Web via SYS-CON TV, we are here in Silicon Valley reaching out to you to present our Lunchtime Focus Keynote by Todd Paoletti from Akamai. And I'm not going to steal his time. 45 minutes, educate us, Todd.
All right, thanks a lot, Jeremy. Hopefully I'm all set up. So Jeremy assured me that this is a world-class box lunch today, replete with dessert, fruit, all the food groups, the food pyramid now, so that he assures me you guys are taken care of. So hopefully you get a chance to enjoy that. We'll talk through some things that hopefully a little bit illuminating, enlightening, and just to kind of get into it. My name is Todd Paoletti. I'm the Vice President of Products for a division at Akamai called the Emerging Products Division. And by way of a backdrop, the Emerging Products Division was formed earlier this year. And we have a charter to look 12, 24, 36 months out on the horizon to look to identify with our customers challenges that they're likely going to be facing in that time frame, or opportunities that could emerge in that time frame that we can help drive and create, leveraging our platform, innovating on our platform, evolving it, extending it, and augmenting it. Not unlike how we've done with video distribution over the internet and delivery, or optimizing e-commerce experience on the web. There are some specific areas that we're focused on across this 12, 24, and 36-month time window. In the near term, we're focused on what we refer to as cloud security. This is really around helping our customers get protection against a massive influx in nefarious attack traffic that we're seeing around the world, originating from a variety of different sources and a myriad of different methods. We'll spend some time talking about that. We're also very focused on helping enterprises, traditional enterprises, begin to evolve and adopt to a public cloud consumption model, and really begin to put application workloads and compute workloads in the cloud and consume them at a much faster rate than they're able to do today. We're also looking at mobility. It wouldn't be an IT conference if we weren't talking about cloud and mobility and how those things relate to kind of the future of IT. But mobility is putting strain, obviously creating opportunity for enterprises, both in delivering consumer web experiences and business application experiences to employees and the extended population. That creates challenges with respect to not only how you deliver and support those devices, but how users who now have a very different profile are accessing applications that now have a very different profile in the cloud. Now, it always helps as you try to look out into the future and figure out what might occur there, to get a sense of where you've been and where you are currently. Now, Akamai, on any given day, sees about 1/3 of the web's traffic flowing over our network. 100,000+ servers and 1,100 different networks distributed globally in nearly 800 cities around the world. Hyper-distributed points of presence and a lot of web-based traffic flowing over our network. So we see a lot. And it gives us a good vantage point to kind of look for pattern recognition in particular areas about what's going on the internet and how the internet might evolve and be used in a broader context. Let's just start with some of the basics, the number of users on the internet. In the last 5 years, we've gone from around 20% of the world's population to nearly 1/3 of the world's population connected to the internet, doubling in the last 5 years. That's tremendous growth. A lot of this is driven in part by the proliferation of connected devices. A tripling of devices that are out there in the world that are connected to the internet exiting this year, approaching 6 billion. Clearly, this is symbiotic with the number of internet users, but this creates a tremendous amount of opportunity to leverage the internet and leverage the web in new ways and consume more of it. And speaking of consuming more of it, we've seen a 10-fold increase in the amount of data in any given month flowing over the internet, from 3 petabytes to nearly 33 petabytes exiting this year. Tremendous, tremendous amount of data now flowing over the internet. This creates a lot of opportunity. We've seen a tripling in the amount of e-commerce transactions in dollars flowing over the internet in that period of time, approaching $750 billion exiting this year. This completely changes the retail experience and the shopping experience. Brick and mortar stores are no longer places where you go and buy things. They're places where you go and browse and look for things that you go buy online with your handheld or your device or back at your PC. Now, with all of this good and this potential opportunity and these new revenue streams, obviously comes the potential for bad activity. We've also seen a 10x increase in the amount and the scale of attack traffic that's occurring on the web, from 24 gigs a second to over 200 gigs a second exiting this year. And the types of attacks, the purpose of the attacks, the sophistication of the attacks have all grown. And we'll talk a little bit about that. And then finally, cloud. A 10x increase in the amount spent on software as a service. This is by far the largest category in terms of spend and momentum in the cloud computing space. Of course, driven by the poster child, which is Salesforce.com. But exiting this year, around $33 billion spent in for-rent applications that no longer live in your corporate data center in a packaged application license model, moving to the cloud. Now, that's been some tremendous growth in the past 5 years. But if we paint this out forward 4 years from now, it gets to be extremely exciting and a little bit scary at the same time. We'll see nearly 45% of the global population connected to the internet. We'll see another tripling of the number of connected devices to 21 billion. We'll see nearly $2 trillion in e-commerce related spend in that time frame. The amount of data flowing over the internet in any given month grows dramatically. The attack traffic, unfortunately, grows dramatically. And cloud, and SaaS specifically, will grow to approaching $100 billion in that time frame. And that's fantastic, fantastic growth. So let's drill down a little bit on that. How do we help enterprises? How do enterprises and how does Akamai participate in making that accelerate even faster? The good elements, not the attack traffic. But how do we help SaaS and cloud adoption grow even faster? Now, if you layer on top of the $95 billion in spend, $100 billion in spend on SaaS applications, the rest of the general public cloud, infrastructure as a service, and platform as a service spend in that time frame, this is according to Forrester, you approach around $200 billion. And that's been fantastic growth, effectively from the industry that we've all helped create and foster in a pretty short period of time. But what's telling is you pan out and look at that cloud spend in the context of the overall IT spend globally in that time frame, it's just a fraction, 3%, $3.6 billion in IT spending in that time frame. So we have not even begun to put a dent in a shift to a cloud-based model. Now, clearly, this all won't shift, but we think there's a lot more room to run faster if the right things begin to fall into place. And we think there are some constraints as to why this inflection point hasn't hit faster or won't hit it sooner, that we need to begin to chip away at and break down in order for that growth to really accelerate. In the old model, before iPads and before BlackBerries and before cloud computing infrastructure or rentable software, it was a pretty simple environment. Corporations had a data center that they owned. They had racks of servers. They had DBAs and application developers. They had networking teams that connected this all together. They had IT staff to make sure it was up and running, and it was a controlled data center environment. Employees came into the office every day. There wasn't a dramatic trend towards work-at-home policies. They accessed these applications through PCs that sat on their desk, by and large, and it was networked together in a pretty straightforward fashion through a traditional private WAN or LAN-based environment. But as you start to shift to cloud-based models, and as you start to leverage these connected devices for business applications, the environment becomes extremely complex. All of it creates a tremendous amount of opportunity, but complex in order to manage it and coordinate all of this. And certain things have not changed yet. I can obviously, this whole audience knows that I can go out to Amazon this afternoon, stand up an application workload with a swipe of the credit card. I can go to Salesforce's site.com, platform as a service, a content management application living in the cloud, sign up for a content management license, build a website, publish it out, and deploy it and run it on Salesforce's infrastructure all within a day. And of course, I can rent my packaged application now directly from the cloud. But the proliferation of devices and the proliferation of user profiles and workforce trends creates network complexity. If you're using the cloud model in this way, you need to use the internet more than you did in the past. If you're connecting users over remote mobile devices, leveraging Wi-Fi, if those users are free to roam, if they're free to travel, if they're free to connect over 4G, 3G networks, you need to incorporate the internet as part of your overall enterprise fabric. And so this creates some complex environments. So now you have to deal with a number of different aspects of your IT strategy. What we refer to at Akamai as you have to have a situational strategy. You have to have a situational enterprise. You're going to continue to have a traditional data center, like the first picture here. Racks of servers, you'll own them or have them in a colo, networking teams that connect them, application developers developing new applications to run on them, and you'll stand that up. You'll also have a data center that looks like the next picture. This is a picture of Rackspace's new cloud data center in Oregon. And hopefully everyone has some appreciation for the amount of density and real estate required for a cloud data center, these mega cloud data centers with Amazon and Google, Rackspace, clearly HP, and the rest. They require a lot of real estate. They require a lot of power, efficient power. You don't drop these things into Midtown Manhattan. They're placed in the middle of nowhere, frankly. They're placed next to rivers that have close proximity to hydroelectric plants that can be accessed for cheap cooling and energy. The Economist ran an interesting article a couple of weeks ago on this very phenomenon, and the title was called No Cloud in Sight. That these data centers, where all of our applications are going to be residing in the future, are in the middle of nowhere. And unless you happen to be in the business of running a kiteboarding operation off the Hood River, your employees are going to be nowhere near that data center. They're going to be the proverbial stock art photo of the employee cruising through the airport on her machine. And so these are things that become challenges. Geography becomes a challenge where it didn't before. So let's look a little bit more closely at some of the other challenges with migrating to a SaaS-based environment. When we look at this marketplace, we break down the types of different SaaS applications we see shifting in different times. Email is one that we've looked at fairly extensively because we think it's going to be a very large shift. It'll take a little while for this shift to happen. We think it'll be a very large shift. In the next 5 years, there'll be almost 700 million corporate email accounts. It doesn't include your private Gmail account. 700 million corporate email accounts. We think there'll be around 200 million of those based in the cloud. IBM feels this way, Microsoft feels this way, Google feels this way, Gartner, Forrester, and the rest. Roughly around 200 million that are cloud-based. And so that's a pretty big shift to where your email is going to live, your corporate email is going to live. Now, there are challenges with that need to get broken down or need to get solved for in order for that to happen successfully, in order for it to happen fast. In the traditional model, where you've got your Exchange server on your WAN or your LAN, and it was in close proximity to your email users, you didn't have much of a problem relative to bandwidth constraint or congestion on your WAN links relative to sending email back and forth. And when you added employees, they came in, they interacted with other employees, everyone was sharing PowerPoint files through the Exchange system. It wasn't really that much of a challenge because there was close proximity to that email server and the bandwidth wasn't a problem. But when you begin to shift that application, the Exchange server itself, out of a controlled, localized environment with fat bandwidth out to a cloud-based model, you have to run it over the internet. So now you're no longer with close proximity to that Exchange server. You also have to deal with the congested internet link. This is an issue that you didn't have before. So now you have users coming into the office. They continue to come into the office. It loads up your internet link because you need the internet link now to get access. The internet link was not something that was a mission-critical, relied upon component of the network architecture because the business applications were inside the network. But when they move outside the network, it becomes core. And so it becomes strained. And it's not just the email that gets strained. It's the Salesforce.com application that gets strained. It's the general purpose web browsing or other internet access that gets strained. And so redesigning network topologies and internet topologies become an important part of the strategy as you migrate some of these applications out to the cloud. Now, earlier this year, Akamai endeavored to solve this particular problem. We partnered with Riverbed. Hopefully everyone is familiar with Riverbed. They are the market-leading WAN optimization provider with about 50% market share. Extremely sophisticated and solid technology, especially dedicated to optimizing Exchange email. They also have a footprint inside the private network. What we jointly realized together and what customers were telling us was that they want to shift to a cloud-based model, but they don't necessarily want to shift everything. They don't want to change that network topology. Most organizations have a network topology where the internet is centralized. The internet access is centralized. Users do what's called a backhaul across the private MPLS network to get to an internet gateway to go out to the internet. This just adds complexity and geography. A user down here in Santa Clara might have to backhaul to an internet gateway that's in Chicago just to get out to the internet, come back over to San Jose where a Salesforce data center might be just to interact with that application. That just adds distance and latency. That becomes problematic. So you need to be able to solve for this. So what we did earlier this year is we took software that lives inside the Riverbed Steelhead appliance. Out of the Riverbed Steelhead appliance, a lot of their optimization technology and their email compression technology. And we put it in Akamai servers in a very distributed fashion around the internet. Effectively extremely close, 10 milliseconds away or less from the email cloud servers. And so we had close proximity. And we put Akamai software and took it out of our network edge servers and put it inside these Riverbed Steelhead appliances. And that created an end-to-end fabric between the private MPLS-based WAN out to your remote branch user here in Santa Clara and the internet data center out in the cloud. And without having to change your network topology, you were able to get an optimized experience where we are routing traffic effectively across the Riverbed-enabled topology, optimizing that and compressing that, and then out to the cloud and providing optimization on the other end. Now, to give you a sense of the before and after, sending an email file in this environment, 9 meg file, both an upload and a download, from San Jose through a Chicago-based internet gateway egress point back out to California to interact with that Exchange server, there's an excruciating experience. This is an A/B test that we ran on a 9 meg file download through Office 365 in the cloud. Downloading this PowerPoint file, making some modification like we all do, attaching it back to an email, sending it back out to your colleagues through an upload, takes even longer. But when you have the joint solution that we put out in the market with Riverbed in place, we're able to optimize across the private network and out over the internet using route optimization and other techniques to dramatically improve that user experience. And we've seen a 200% on average experience improvement for handling basic email attachments once that email moves out to the cloud. And again, so solving for this kind of network congestion and optimization is going to be really important for cloud email to have success, to be able to shift from and achieve the 200 million potential email accounts that are going to live in the cloud, almost a third of them over the next handful of years. But the shift is moving there. Major players like Microsoft and Google with Google Apps and IBM with Lotus Live are driving the market to that. But there are considerations that have to be made. So shifting away from software as a service into the world, obviously, of cloud platforms, infrastructure as a service and platform as a service. Akamai also realizes that it's going to be important for cloud optimization, cloud-based workloads to succeed if everybody has scale and optimization and acceleration for any type of workload. And so what we've done is we've worked with some of the leading cloud platforms out there. Rackspace, HP Cloud, Salesforce with their platform as a service force.com and site.com specifically, to embed Akamai content delivery into those environments. So you go here to Cloud Files, and with the click of the button, your files and your access to your files are replicated and distributed out of the Akamai CDN. Because we think proximity and performance is really, really important in order for public cloud to continue to grow and to continue to succeed, to go beyond the 200 billion, to go beyond the 3% market share. The geography challenge has to be solved, and so we're looking to begin to solve it in a number of different ways. And this is one of them. So we're very proud of our partnerships with these leading cloud providers. So shifting gears a bit, the other aspect of what we're looking to solve for in our emerging products division is around making the mobile experience faster itself. As we talked about this new environment, no longer a simple environment. Application workloads are no longer in a fixed place, but users are no longer in a fixed place either. They're no longer on a fixed, constrained Windows 95 environment. You've got no idea what kind of device they're likely on if you've got to bring your own device strategy. And so you have to be able to optimize that, especially when you're dealing in the consumer world. Right? All of this internet traffic, the growth in e-commerce, a lot of it driven heavily by mobile. So specifically, 66% of all shoppers, online shoppers, use a device while they're shopping. Again, the device becomes simply another way to understand and have an interaction with the product in the inventory. 30% of folks use 2 devices. A third of them are actually making purchases primarily through a connected device. A third of all shoppers have made at least one purchase in the last 6 months on a mobile device. So this actual physical store no longer is where you go to buy stuff. It's where you go to check stuff out that you buy on your iPhone. Now, it's not this challenge or this opportunity obviously isn't just constrained to the consumer world. Enterprises obviously are dealing with this as everyone has at least one device in their pocket right now, one on their lap, hopefully closed, eating their lunch. 80% of employees use a personal device, and they're accessing more and more types of applications on these devices. They need these devices for more than just email. Obviously, RIM was extremely successful with the BlackBerry, earlier last decade, but it's gone well beyond email to different types of applications, rich applications accessed over mobile devices, in large part Wi-Fi, but it's not just Wi-Fi. And so to be successful delivering an application, whether it's a consumer or shopping experience or a business application like WebEx to your user, you have to be able to understand and optimize for the myriad of device optionality that will likely exist. You have to be able to anticipate network latency or delay for that real-world experience that's going to be ingested because of the wireless carrier networks over the air. The different device form factors, the capability of the device, the CPU and rendering power of the device, the types of applications run on the device, the browsers and the form factors all have to be taken into account. And then last but not least is geography. This user, again, is going to be Maybe they're close to the application physically and latency gets reduced because of that. Maybe they're not. Maybe they're far away. But they expect the same experience regardless of whether they're next to the application or 1,000 miles away from the application. And that's the key thing. The level of expectation of interactions with web-based applications and internet applications, whether they're business apps or consumer apps, continues to go up in terms of what they expect in terms of performance. They expect performance to continue to go down. So I want to give an example of one of the things that we're innovating on here at Akamai that helps solve this particular challenge, just one of the many things that we're working on. It's a capability that we refer to as adaptive image compression. You know, again, 110,000 servers distributed globally in 1,000 different networks in 800 different cities. We see a third of the web's traffic every day. We can do some pattern matching on what the traffic profile is, and more specifically, the user profile is. We have the ability to understand what their network environment is and the latency of their network environment, whether they're coming through on pure Wi-Fi or Wi-Fi over a 3G, 4G network. We understand the device profile on the OS and the window size, for example. We generally understand the throughput that they're coming in on. Then you can't deliver the same content set to everybody. If you were to deliver a high-res image to somebody with a poor connection, that's going to be a disaster for that person. But they all still expect sub-second, sub-2-second response time for what they're dealing with. But you want to optimize for the highest quality that you can. And so what we do is we take all of the input from the devices, from the network connections, from the throughput knowledge, and we optimize using the software on our network to deliver it the right format of the content. So in this example, we use the 54K version of this particular digital photo that we've taken, and we deliver that out to the user who's accessing with high throughput. We shrink that down and compress it to half that size, more or less, and deliver that out to the user who's got half the throughput. And generally what we're able to do is give a consistent experience for all of those users, fast experience for all of those users, no matter what device they're coming in on. And so we have to be able to employ these types of techniques in order to maintain high quality experience, because that continues to be obviously in high demand. As an example of what this looks like, this is a baseline test, A/B test on this particular image here. And the challenge that we run into is the latency that's introduced by coming over a wireless spectrum, the 3G spectrum. When you do that, it introduces, in this case, around 4.5 second performance hit, latency hit. When you add in the adaptive image compression technology, we can't completely overcome for some of the wireless spectrum challenges and latency associated with that, but we can really shave off some of the degradation that was introduced because of that. In this case, 1.5 seconds we've now recovered from the introduction of the 3G spectrum because we've been able to optimize the experience and apply the right compression capability for that particular image. So shifting gears a bit, we've spoken about a number of macro trends. We've talked about the shift to cloud-based application workloads across SaaS and infrastructure and what will be required in order to make that continue to go. I want to talk a little bit about what we generally refer to as protecting the cloud or cloud security. And this part's a little bit spooky. 74%, 3/4 of companies in the past year experienced at least one DDoS attack. Doesn't matter if you're a small company, big company, doesn't matter if you're a media company or a bank or a government or you sell spark plugs or you're doing retail e-commerce. Nobody is immune to this. 30% of those guys actually had some service disruption, either being taken completely offline or a serious enough service degradation that they lost business or lost some uptime because of this attack. So that's not good. On average, each breach that was recognized cost the company around $8 million bucks. So not only is it something that you have to spend money on and building out infrastructure, potentially for in order to absorb, protect against, and think about constantly, it costs you money anytime you get hit. Now again, with the overlay network that we have and the amount of traffic flowing over us, we see a lot of these types of attacks. There's general DOS protection capability that's been in the Akamai system from the dawn of time. The ability to essentially absorb attack traffic or absorb any kind of traffic and spread it out. Attack traffic is, in one sense, a class of just traffic. So we remove scalability requirements on behalf of the application of the website origin just naturally. But we've become much more sophisticated, in part because we've had to. You can see over the last 3 years just the simple number of attack traffic that we've witnessed among our customer base, seeing nearly 500 individual attacks executed against our customer base in the last year, 2011. And they range from small to large. The average is in the 3 to 10 gigs a second range, but we see very large attacks approaching 200 gigs a second. So they obviously are coming more frequently. They're getting more sophisticated. So this is a bummer as well. It's not just a single type of attack that you clearly have to protect yourself against. They become more sophisticated. The DDoS denial of service attacks that we would naturally be able to help prevent are only maybe a quarter of the type of attack traffic that we see out there. And the largest named category here is what's called a SQL injection attack. This is a layer 7 web-based malicious attack where the bad guy is effectively trying to enter the system and take information out or enter the system and do something nefarious once they're in the system. That's unlike a denial of service attack, which is intended to make the service and the website, the web application, unusable. And so the type of traffic or the type of application attack is become varied. Now what's also continuing to evolve is why, the motivation. No longer is it simply a group of hackers in dorm rooms trying to go for bragging rights and taking down a particular website. That certainly remains part of it. But what's evolved is a whole term for a movement called political hacktivism. And we're all clearly aware of Anonymous and some of the activities that they've been driving. Now, these more sophisticated layer 7-based attacks are in large part motivated out of the intent for profit. Entire black market industries exist for selling and purchasing attack tools and software, but obviously selling and purchasing what's been gained once you've come into a system and effectively robbed somebody. Selling credit card information, for example. Huge black market initiative. So profit is a major driver now. Now that there's more commerce and more sensitive data that's available on the web, obviously you're going to draw some attention there. And then, of course, state-sponsored attacks, cyber warfare, cyber terrorism continues to be a large threat. Of course, we saw Leon Panetta post a warning about this and make a statement about this just about a week and a half ago. And this comes from a variety of sources, obviously. You can imagine the source options here. So many different types of attacks, too, that have to be protected against. So what we've done in our emerging products division is to begin to get maniacally focused on helping customers and their web properties protect against these types of attacks. We've invested heavily in building out the network to absorb massive spikes in attack traffic. This is an example of a sample set of 5 customers during last year's Cyber Monday buying season. 48 hours in there that are the most critical to online retailers and most retailers just in general. We're coming up on that in the next handful of weeks. And you can see here, just looking at customer number 1, a 9,000 factor increase in the amount of traffic that they experienced during that 48-hour period. And this is above and beyond what they were normally planning on for the holiday buying season. Clearly it's bigger than normal. But 9,000 times above normal is a little suspicious. So clearly that was an attempt to take down that particular site, 5,000 times greater than normal, all the way down to 1,800 times greater than normal. So these are serious attacks that have been launched on these properties in a very short period of time. Not a single customer in this sample set had any degradation of their online shopping experience at all, because they're leveraging the Akamai DDoS prevention technology and service. We estimated, even in that short period of time, that by helping these customers stay up and maintain high-performant websites, that we saved them roughly around $15 million simply in a matter of a handful of hours. So it's material. So those were DDoS attacks. This is an example of attack traffic that we saw during the London Olympics. The Olympics every 4 years are a major event for us. They drive a lot of traffic, primarily video, across the world. So this is a look during a one-day period, a 24-hour period, on the amount of attack traffic against a class of Olympic websites, primarily delivering streaming of events. And what's interesting about this is in that 24-hour period, we saw about 23 different types of sophisticated attacks. These are these layer 7 types of attacks that we're looking to enter the system. We saw a 40x increase in traditional DDoS traffic, trying to create service unavailability of these types of sites. So from both sides, we're protecting these flanks. We have, running at our edge, we've built this over the last handful of years, a web application firewall, hyper-distributed web application firewall. We're protecting against these sophisticated attacks out at the edge, nowhere near the actual origin system that's serving this site. So you want to fight the war on the other guy's turf, which is essentially the notion here. During this 24-hour period, we fired off 25 million different types of rule sets blocking different types of attacks. And so a tremendous amount of activity in protecting our customers against attacks. And not a single customer in this period had any degradation of service. It just simply gets absorbed and blocked and distributed out. So we talked about denial of service attacks that are traditional. We talked about sophisticated layer 7 attacks. This is a look at DNS-based attacks. We also have the ability, because our service runs on DNS, to extend a secondary DNS service to protect customers against this. This is a particular bank, large global bank, who saw a massive spike, 23 gigs a second, 10,000 times normal traffic for this particular day, that we absorbed. And this attack lasted almost 5 hours. This is a serious attack attempt to take down this financial institution. And they saw no degradation in service during that period of time. So look, I'm going to wrap it up, let you guys hopefully enjoy the rest of your world-class lunch that Jeremy promised that you had. Hopefully you're onto the dessert, if you're into that. I'll take some questions off to the side here. My email here is posted on the screen. Please send me any information, again, or questions that you have. Again, Akamai we've been in the business of optimizing the internet for a dozen years or so. And we see a lot of opportunity ahead of us. We obviously see some challenges ahead of us as well. But we continue to innovate of what happens and occurs on the edge of that network in a more sophisticated way to help drive adoption to cloud, to take it from 200 billion to 500 billion, to continue to protect our customers against attack traffic, to optimize for this explosion in mobile device connectivity to traditional web-based applications and other applications. And so, very much like we've continued to innovate over the last 12 years on different trends in the internet space, we'll continue to do that moving forward. So again, if there are any questions, please come up, and thanks for the time.
Thank you, Todd Paoletti. Let's agree where to go.